as discharging the water. So we have to keep all of these costs in mind, because that's one of the levers that we have to help motivate our companies to be interested in water efficiency and to actually act on some of the recommendations. So how do we use water in the workplace? We use water in the workplace for washing and rinsing in a variety of ways, both by hand and spray wands and hoses, as well as many, many tanks and cascading rinse tanks. We use water to transport product from one place to another, to wash it as an ingredient, and as a very important ingredient in sanitation to keep our processes clean and healthy. Water is used for cooling and heating in large quantities. And water is also used to treat water. Surprisingly enough, both water softening and reverse osmosis treatments do take a lot of water to get yourself some pure water. So those are, even the water treatment processes are things we can look at in an industrial situation. Domestic water is another usage, depending on the facility. This could be a fairly major usage, and especially when we consider irrigation. Irrigation is often a large source of water that people forget about because it may happen when people are not at their work site. So where do we begin? How in the world do we begin managing water, assessing water, and water use at an industrial site? Well, over the course of the years, MnTAP has analyzed our process and has found that this kind of approach of mapping and maintaining, managing, and modifying, these keywords, the 4 M's, are how we really approach our water efficiency work. Mapping is number one. Mapping is understanding where your water is used. Maintaining is making sure everything is working the way it's supposed to. Managing is making things work better. And modifying is, let's rethink how we use water. And so we'll go into each of these with an example. So mapping is to get a picture of how water is actually used throughout the site. And this is an absolute must first step for any water assessment, because oftentimes we or the folks that we're working with at a facility may think that they know where the water is coming from or going to, or where the sources are. And oftentimes they do, but sometimes they misjudge, or they miss something, or a leak has sprung up that they can't see. And so it's always good to make sure we are accounting for all of that water. And it allows us to get the best return on our efforts. So we want to work on the things that are the biggest, that have the biggest impact on the facility water use and their long-term strategies for continuous improvement. So we're looking to measure, value the water, and make a plan. So mapping, here's an example of mapping water use at an Aveda plant in Blaine, Minnesota. They used 22 million gallons per year of water, and they knew from a rudimentary balance that they used about 25% of this water in their cleaning operations. And they wanted to reduce water use and cost. And their motivations really are, I don't know if you know, but Aveda is a company that's very high on their sustainability portfolios and really cares about their environmental footprint. So this was a high motivation for them. So the approach, this was most of the examples, I just want to reiterate, most of the examples that I'll be sharing with you today come from our MnTAP intern program. So these all have case studies associated with them, and those little links down at the bottom that you can't even read, that's where you can find these. The approach was to analyze the water meters, understand how water was used in the cleaning processes and sanitation processes, and measure flows of things that they didn't know where things were going, and talking to people who were using the water and looking at water reports. She put together this gorgeous map that is on the right-hand side of the slide, and it was really complicated, but it was very beautiful, color-coded, really gave them an excellent picture of how water was being used in their facility. And with that, they identified one particular room, called the sanitation room, that used about 15% of the water. There were 4 operations that went on in that room. And they made changes to two of these. One was using a high efficiency spray nozzle. So spray nozzles are really something that you can run into a lot. Older ones or ones that are broken really can leak a lot of water and not be real efficient for cleaning. And then a high efficiency spray ball. So higher efficiency water use equipment is readily available and really usually very cost effective for changes. The savings was about 1.4 million gallons per year, about 40% of the area use. And it was hot water, so there was a lot of energy that was associated with that. And they ended up saving about $20,000 per year. And one of those things that I'll kind of mention here, and I may mention several times as we go along, is that hot water is like a triple win for you as a pollution prevention provider, because not only are you going to be saving the water, you're going to be saving the energy that was associated with treating that water or heating that water. And that also brings with it greenhouse gas savings. And then chemical savings can often be associated with that if the water was softened or something like that, or if there's other chemical uses. So lots of advantages for managing hot water. How do we make a water map? Well, we meter, we measure, we estimate, we kind of figure out what's flowing where through the operation. So we have to figure out where can we get to information, what information is available, is it accurate, can we verify it in any way? Sometimes we can, as we're walking through a site visit, we might get some visual clues that something funny is going along with the water. If you see a trough that is filled with water, or if you see a puddle, or if you see a hose that's just sitting on the floor, whether it's running or not, you might ask about that in terms of these types of hoses. You can see that 1 gallon per minute to 6 gallons per minute, depending on how fast the water is flowing out of that hose, is a tremendous amount of water use if it's just left running during operations because it's just too much bother to go over and turn it off. Well, that's an ideal case for a shutoff, an automatic shutoff valve at the end of the hose, and you would save loads and loads of water that way. Other strategies for water efficiency are to maintain. So do your maintenance on your operations, fix things that are broken, repair the existing process to bring it back to operate as it was originally designed. Inspect, repair, prevent, and repeat, because oftentimes if things are a maintenance issue, it means that they can be recurring. This is often low-hanging fruit, but it can offer a lot of water savings. Low cost within the maintenance budget generally does require staff time, and staff time these days is incredibly short and limited. It is often postponed. Maintenance is often postponed if it's not urgent, because there's always something urgent going on in a manufacturing facility. And prevention is possible by analyzing the leaks, the incidences, the recurrences, and adding up like a preventative maintenance schedule, or changing out part of the process that has a high propensity for maintenance issues. This is an example from Diasorin company. This is again another intern project, and their motivation was that they had 8.5 million gallons of water use. However, they only thought they had 5 million gallons of water use based on their assessment of their facility. So there was 3 million gallons of unaccounted water, and they were going to get charged for that water from a service availability charge to the wastewater treatment facility, because you get charged based on your water usage. That would have been up to 74 SAC units at $2,500 per unit. So it was kind of a big charge that they were facing unless they could get their hands around what was going on. So their initial map looked like the one on the left, where they had about a third of their water or more they couldn't account for. They didn't know where it was. So the approach was the student intern created a map of the water use in the facility and was able to close the water balance. So we didn't have this big gap in what we were missing. And they were able to identify reduction strategies. And what was missing was a leak unseeable leak. It was underneath some equipment. The facility had a detailed inspection. They didn't see anything that they couldn't find. The city meter was working properly, so they verified that. So the water was really going in. What they found was that there was a vacuum system, and there was a liquid ring seal, and it had corroded. So the water was coming into the seal, just flowing right out to the drain. They were looking at about a 3 gallon per minute continuous leak day and night, about 1 million gallons per year directly to drain. Never did anything good for that facility. They also found that they had a broken flow meter. What they thought was flowing at 2.8 gallons per minute was actually flowing at 12.8 gallons per minute. Quite a big difference. So between those two repairs on that one piece of equipment, there was their missing water, the 3.1 million gallons, saving that company $23,000 a year and no additional SAC charges. In addition to that, the student also found that this facility had domestic water use, and their hot water was often softened because this was a critical requirement for their processes. They were unable to maintain the low hardness of the water. However, if they let the water sit, it would become harder. So there was some hardness seeping in somewhere. That required them to do a system purge, a constant system purge, which was costing them about 15 to 16,000 gallons per year of water, just to keep the system clean enough for them to do their work. So they inspected some of the places where they expected a crossover between the cold city water and the hot softened water. And they found that under sinks and in the safety showers, there was crosstalk between some of the valves. The valves had corroded, the valves were old, the valves were leaking, and the city water was leaking into the high purity hot water. So they fixed those and made sure they had one-way shutoff valves. They also had opportunities for some domestic usage, which was found as they were really combing the facility for additional water opportunities. So easy conservation opportunities, leak identification and repair is really top of the list. Managing water is optimizing what you have and making it work better. So instead of having a hose, you might use a high pressure, low flow hose spray head, high efficiency equipment, add some automation so things turn off all by themselves. This is a second level of complexity, and it can still be achieved at fairly low or modest cost, and usually within using internal resources for changeouts. It resets your operation within your current system limits. So essentially you're doing what you do, but you're doing it better. Retraining operations staff might be involved, changing SOP practices. So it may not be a piece of equipment, it may just be making sure people are following their SOP practices or improving on them, a continuous improvement opportunity. Adding controls or automation, things that can shut off automatically, or measuring things in a different place. This is replacing like for more efficient like. This is a great example. This was a soup kettle in a commercial kitchen in a hospital in the Twin Cities area. Their motivation was that soup kettle was using 1.5 million gallons of 127 degree F water per year. Remember what we talked about with hot water. Hot water is a super boom. And it was often left on overnight. So you can see the two small pictures on the right. So we had at the bottom of this, I don't think I can see this on the bottom of the soup kettle for running the water was a hand valve, right? And so people had to run it for a certain amount of time after the soup was done. And you know how people get super busy with their jobs. They put something on, they'll go do something else, and you forget to come back, and it ends up being stayed on. So what they did was they replaced that with a solenoid valve, the one that would stay on for 15 minutes and turn itself off. That was about a $26 investment plus installation. They were able to save 1.3 million gallons of water per year, 7,000 therms, and $13,000 per year from that small change that they were able to make. And the workers don't have to remember to turn things off. Another one is Federal Cartridge in Anoka. You can see here how their washing system looked. That looks like a fairly low tech hose valve. Essentially, it's just an open pipe pouring into a bucket and rinsing off their product. They were trying to manage their operational costs and using their on-site, maximizing the ability for them to use their on-site wastewater treatment system so that they could also avoid those service availability charges. So they instituted a few different things. They instituted a timed rinse cycle on the product. They changed out that open hose for a high pressure, low flow hose nozzle, which was able to increase the cleaning efficiency and increase the throughput. So bonus, we got additional product through the line as well. They added some automatic shutoff valves and they started using some recycled water, which is a different type of process, but it was actually a really good boon for them. Again, they saved about 5.5 million gallons of water and $83,000 a year. So the business case, so what I'm hoping you get from this is that driving change often requires building the business case for your water efficiency projects. And sometimes that means going beyond just what the cost of water is. It might be including the cost of treatment, the cost of heating. It may include operational throughput changes or labor costs that might be decreased. So these are all things that can go into justification, the business justification. Conservation opportunities, no water cleanup options. It's very easy to get out that hose and spray things down the drain. Sweeping things up and putting them in the solid waste containers can often be a more water conserving and more efficient, cleaner way of doing cleanup operations. Adding pressure or heat instead of volume can also help decrease the amount of water used and increase the efficiency of an operation. Hand valves, they are great for turning things on and turning things off. They are very difficult to manage flow. And how many times have you gone into a facility and you've seen the little markings on the side of the shutoff valve? Well, if you turn it, 1/4, then it's got this flow. And if you turn it, 1/3, it's got that flow. Very, very difficult to manage your water and get things reproducible. And they may be left on when they're not needed. So improvements are to add automatic shutoff valves, timers, flow controllers, and increase the automation around your valving when possible. Here's an example of a conservation opportunity. This challenge on this one was this tank needed to reach a certain temperature, a hot water cleaning for sanitation, and it needed to be at that temperature. If it didn't get to that temperature for a specific amount of time, then they were not in compliance for cleaning. And they needed to fill the tank to the probe level. So initially, they only had the probe that was on the side of the tank. So they had to fill their tank up with water to the halfway point in order to measure that temperature, even though they didn't need that much water to do the operation. So they added a second temperature probe over on the recirculation loop over here. So that meant that all they really needed was the darker blue section of the fill. They didn't have to fill the tank halfway. They just had to fill the cone and enough to be able to recirculate the water around. And that saved them tons and tons of water. So it's where are you measuring and are you using more water? Just because that's the way things are set up. We can change things. We can add equipment as needed. Modifying is a significant change to a process or equipment. Very high level of complexity, may present some risk or change to the process, and it requires a site champion usually to execute. Process redesign or capital investment may be required, And there is probably more people involved than just you and the folks that you might be working with. This is probably the longest extended time for implementation, but the advantages can be really huge. This is where you can get to the reduce your water, reuse that water, and recycling that water throughout the facility is covers under this kind of modification strategy. Here's an example process at Gedney Foods, the pickle folks. They were trying to reduce their demand of their well supply because they wanted to grow the business at that facility, but were limited by their well supply of water. And they also wanted to reduce their water discharge because that was a very high cost for them. They just wanted water not to be a bottleneck for production increases. So the approach was to figure out where they were using water and identifying some water savings options. So they were using a pasteurizer overflow system. And so the steam and hot water, the suggestion was to reuse some of this steam as makeup water for a hot water feed. Don't just let it blow out. Capture that, bring it back to your hot water. Fermentation brine, they were using fresh brine for every tank, and the proposed was to reuse a portion of that brine in each tank. And so that way they would be utilizing it. They would be eliminating less water and less salt, a lot less salt. This was a process that would save them 5 million gallons of water. Over 200,000 pounds of salt. It's amazing how much salt that one was. And that's becoming quite an issue for Minnesota as salination of our surface waters is becoming more and more noticeable in some of our waters and is being regulated out of some of the wastewater plants. So that is actually something that our wastewater plants are very, very interested in seeing. Again, this is hot water, so heat energy savings. Overall savings of about $32,000 when that process is implemented. Again, another company, Ball Corporation. Ball Corporation makes packaging for beverages. And the motivation on this one was they use 26 million gallons per year of water at this particular site. And water is being, accounting for that water is actually being demanded of their supply chain partners. So someone upstream is asking them to account for their water and to make actions to decrease that water. And so this is an external pressure now that's coming at them. And so they were assessing the water use in their operations to identify opportunities for reuse. And they have a wastewater facility. They have a water pretreatment facility. And what they were using was a lot of city water to dissolve their lime in their lime silo and use that for a wastewater slurry feed. However, they were making really pure water at the end of that process. So their idea was to reuse the water, the wastewater that they were currently discharging to the wastewater treatment facility, and reuse some of that water for their lime feed instead of using city water. So they recommissioned some existing equipment. So this was not a new idea. This plant had been doing this before. They modified the process for reliability and they demonstrated the impact on water. And so essentially they were reusing a lot of that water that was formerly going to wastewater within their process. So they were able to save 5.7 million gallons of water with a $55,000 a year cost savings and gave them less than 1 year payback on this operation. So pretty impressive what they were able to do. And they get to report this to their customers as an improvement. This is a craft brewery. They did everything. They mapped their water to figure out where it was going and how they were using it. They found some broken equipment that they could maintain and fix and decrease their water that way. And then they were able to really reconsider how they were using their water by installing some efficient rinse nozzles and reusing some of the water that was used for inside the can washing so that they could capture that and then use that same water to rinse the outsides of can after production. So they really took this to heart. So this was great. So that was our strategies for water efficiency. Process technical assistance, mapping that water, key, very key. Maintaining your operation. Maintenance is important. Don't let those leaks persist. They, especially if they're hot water leaks, they are going to cost you a lot of money, and they're going to create a lot of water waste. Manage the water, do what you do, but do it more efficiently, and modifying your water use by rethinking how you use your water. Okay, so at this point, we can either talk some questions or we can head over to the water treasure hunt. So I'm going to stop sharing at this point and we can come back. Pam, I don't know if you want to think there's any questions or anything, or?
Well, I mean, let's ask. Anybody who has any questions for Laura about the case study she just shared, now is a good time to ask. So just unmute yourself and we'll keep going. So Jim, can you go ahead and ask your question directly?
I see the SAC chart as you mentioned, and I just didn't know if that's total water per year charge, or is it the instantaneous sort of daily maximum, or how is it calculated? Depend on town.
It's calculated off of the amount of water that you use in a year. So essentially it's total volume, not instantaneous volume.
Great. Any other questions for Laura? I see we have.
One more. I have one more.
Okay.
Jill.
The brine, was there any treatment of the recycled brine? Oh,
Yeah, so was that for the pickles?
yes.
Yes. Yeah, so that was a real concern for them. That was a situation where they had a pretty significant process change there, and that was an operational change. They were quite concerned about its impact potential for quality. And so they had to weigh whether they wanted to implement that or not. We gave them, as many recommendations as we could. It took them quite a while. They decided to do it very, very slowly at first, and just use a very small portion of that back so that they could really get into that. So they staged that. They're still not using 100% of it, but this is something that they're comfortable with. They're moving at a pace that they're comfortable with, but they are still moving forward.
I guess my question was, are they screening the brine? Are they coarse filtering it? Are they ultra filtering it?
No, they wouldn't ultra filter it. They would probably screen it because, they're putting pickles in it. So there might be stems or sticks or leftover pickled guts or something like that in there, but I don't think they would do anything else with that.
Pickle guts, awesome. So Jill, I saw you had a question, and then Mike. Go ahead, Jill.
Yeah, Laura, I'm just curious, how many projects do you and your team work on every year?
Oh, golly. Lots.
Okay.
We have about 15 to 20 students, as I said, every year. And so we get a project for each one of those. And then
wow.
They work on those over the summer for about 500 hours. So we're setting up those projects and following up with those projects. But the students really kind of do the bulk of the TA type work and lining things out. Then we, that's the summer. And then we're probably, I should know this number. I would say probably, let's see, how many site visits did we do last year? About 70 or 80.
Great.
Yeah. Wow. That's great.
Yeah. So
Mike, you had a question.
Sure. Thank you. Thank you, Laura, for your presentation. I think you noted earlier that you're using groundwater as well as a surface water supply. Is there significant difference in the chemistry of one or the other that you have to take in consideration with treatment? If treatment's necessary, are they pretty much the same?
Well, I would say treatment is more site dependent than water dependent, right? So if a facility is doing, say, medical devices or something where the water is an ingredient, they're going to be taking a lot more care with how they treat that water to make it more consistent. If they're just using it as a rinse, perhaps non-critical type of situation or a rinse, then they may not be using it so much. And even if they're using a well or a surface, again, oftentimes they're using city water. So different cities are getting their water from different sources and have different mineral profiles for different wells that are used from different cities. So usually what we see is that a facility will take in city water or their groundwater, and they're going to also have a pretty extensive treatment system to get it where they need it. And they know that better than we would because they know the constraints of their equipment and their process, and if they're looking for spots or whatever on the surface of their things. Minnesota has pretty hard water, so water treatment is more the norm than not.
Yeah, and one last question. I mean, I don't know. Well, naturally, this depends upon your use and the level of cleanliness that you need with the water. But at some locations, you may have acres and acres of, let's say, rooftops with rainwater. Is there anything that you look at or assess the collection and use of that rainwater, and instead of it just going off into runoff?
Yeah, rainwater is an interesting animal. It is usually, it's something everybody would love to, you know, they look at those massive roof areas and they go, ah, right, that would be awesome to use. I've seen it used for irrigation purposes. So they will collect and store it for future irrigation purposes. Some places will collect, filter, treat, and store it for domestic toilet type uses and things like that, toilet flushing. I've not seen it used much for processed water because it's not reliable, and it's not always going to be there. And usually processes need a little bit more consistency than they feel they can get with stored water that's been collected from rain. But yeah, it's one of those, it would be nice to have, but I think our technology and our incentives for that maybe need to be improved.
And I have no idea where you're in, more of a desert area or it rains like crazy. I have no clue. Your availability
it
of
used
water.
to rain
So
like
beyond the
crazy,
question.
but last year we had a drought.
No more. Yeah.
So I guess
Okay.
it depends on the year.
Yeah, and we
Thank you.
had a conversation about the changing conditions at our last conference where we talked about how drought is becoming more and more of a concern and something that companies really need to be paying attention to, and an additional driver for really doing water conservation at your facilities.
Yeah. And the trouble with a drought situation is that your surfaces where this water is collecting become contaminated. And you have, much dirtier water coming off of your roofs and things that could cause problems in some of your reclaim systems, just because we have more debris in there that maybe we wouldn't have if it had rained more frequently, or it would have been more diluted out.
Really interesting. Yeah, thank you. So why don't we go ahead and introduce the activity, Laura?
All righty. Well, I will start sharing my screen again. This is, hopefully you're going to have a lot of fun with this one. This is the water treasure hunt.
We don't see your screen. There we go.
I'm getting there. I'm
Okay.
just a little slow. I can't talk and click at the same time. It's a talk and click problem. So let me get this up and going here. Not yet. There we go. How's that?
Perfect.
Good. Okay, so this is actually a fun thing that we do with our interns in training programs. So you are going to be well trained to be a MnTap water intern. So anytime you want to come hang out with us, you're more than welcome. So this is an assessment that we developed over a couple years to just give our students who have never been oftentimes in a manufacturing facility the flavor of what they might run into when they're trying to gather data and make an improvement. And so this is what we get. So we start off with a phone call. So this one, the company called us and said, I need some help. And the situation, oh, and I wanted to remind you, this is something that you have. This is the packet that Pam sent to you. So you have much of the information, the basic information. You don't have everything you need, but you have some things to start with. So the situation was there was a plant that had a 500,000 gallon per year water increase over the last 3 years. And as a result, the sewer folks were coming after them with their sewer availability charges. It was going to be $14,000 for this small business, and they were just really getting nervous about this. Their annual water and sewer costs are about $4,000 per year. So what does this mean? What do we need to do? Well, we need to help this company find over $500,000 gallons per year of water savings. Okay, so that's going to be our job. Well, how much water do they use? Oh, I don't know. What kind of water is it? Is it treated water? We don't know. There's a lot of things we don't know. So it looks like we might need to be, but there is some cost incentive. So there is some monetary incentive for them to avoid this SAC charge. So there's at least some cost incentive for them to do something with us. So, but we need more information. We can't help them over the phone. So we had a follow-up conversation with them. And it turns out that they use about 1.35 million gallons of gallons per year of water. Okay, so this is about, little less than half of their water use. So it's considerable. Their domestic use based on a meter is about 550,000 gallons per year. So of that, 1.35 million gallons, about little less than half of it is for domestic use. And so that's the cost there is about $1,600 per year for water and sewer on the domestic side. Their industrial use is about 800,000 gallons per year, and that costs them about $2,400 per year in water and sewer charges. But we don't really know what's changed with this facility. Have they had a staff increase? Have they had process changes? Where is it being used and what information is needed? So we think we better get out there because we're a little bit bored after having been hunkered down all 2 years with COVID. So we're going to go visit as many people as we can. So we're going to go hang out with these folks and see what we can learn. The company's name is Optics R Us. They have 110 employees and they have 2 manufacturing processes. They make eyeglass lenses. Their first process is a more traditional process where they convert purchased glass lenses or lens blanks, and they grind those to give the prescription that is needed for those lenses. It's a traditional operational process. There are 3 work areas: surface, surfacing, washing and coating, and finishing. They have a second manufacturing process that molds lenses. So these are an injection molder. And they've been operating this for 2 years. Interesting. And they have 3 work areas within that part of the process: the molding operation, the washing operation, and the coating operation. So now we know a little bit more about this facility so we can begin our mapping. And so we can start here. I'm hoping you can see some of that. We've got our incoming water at the top, and it splits off into processed water and domestic water. And I think you have a picture of this in your handout. And the process has 2 processes. So process 1, which is surface, wash and coat and finish, and process 2, which is the molding, washing and coating. But we don't know what the distribution of water is within that facility. So here we go. We're going to a site visit. The trainers are going to be playing the roles of the plant manager, okay? So they can be as I mean, this is going to be Academy Award winning. I am certain of it. And so you can ask them for questions for additional information that you feel you need. They have information on many of these operations. Your objective is to assess the water use in the assigned areas, compile the data to complete our water map, identify water use and efficiency opportunities, and we'll report those out when we come back together, and estimate a reduction potential for this company. We'll be working on this for about 30 minutes. Maybe, you know, if we start getting really bored or slow, because we haven't really tried this out, we can you know, come back together. But I think it's going to take us a little while to get organized and everything. So I think this will be kind of fun. Before we go, we do need to worry about safety, right? We can be the Granger guy. Identify the safety concerns at this facility, determine what kinds of personal protective equipment that we might need, and make sure that we feel safe in this facility. So safety concerns we might notice, there's probably going to be some dust, there'll be some noise, and there'll be wet floors, most likely because there's water around. So how do we take that and translate it into PPE? Well, we probably want to bring our safety glasses, our slip-resistant shoes, and perhaps some hearing protection. So now that we're all ready, we can go to the facility. Okay, so this is where we are. Here we go. We've got the two sections of the operation, process 1 and process 2. There's 3 operations within each facility. So process 1 has glass surfacing. They have plastic surfacing and glass surfacing. There's 2 mini operations in there. They have wash up and coating, and then finishing. And then on the process 2, they mold, they wash, and they coat the lenses. Okay. So those are the operations that we're talking about. All right, so here we go. We're going to look for a water map. We're going to complete our water map. We're going to observe where the water is used, and we're going to make some recommendations like good consultants that we are, and help this company resolve their water challenges. Okay, so with that, I am going to turn it back over
To me.
Yeah.
Let me just remind you all, I'm going to open up the breakout rooms, and you're going to split into breakout sessions. So I want to remind everybody to have the material that I sent to you yesterday ready to go. Have it in front of you. There are a couple of roles that are called out there. There's let me get mine, and I can remind myself, apologies. There's the project manager who's responsible for making sure that, you know, the team accomplishes what your objectives are. There's the data manager, the person who's gathering that data and organizing it. And then there's the reduction manager, that person who's really thinking about where are the water reduction opportunities. So when you break out into your breakout rooms, you can decide if anybody wants to pick up one of those roles or how you want to manage that. It is up to you. And then Laura and Liz and I will be joining one of the rooms. You'll have one of us in each of your rooms. This is where the Academy Award, you know, performances will be happening. I intend to use a variety of voices. It's going to be really fun.
Where are your Groucho Marx glasses? All I have is regular safety glasses. I'm not very creative there.
Yeah, but it's better than nothing. So there's a lot of work to do. You need to know what data you have and what data you need, and we will help you get the data that you need. So I'm going to go ahead and open the rooms. I will give you a countdown when we're going to bring the rooms back together to talk about things, but we're going to give you plenty of time to work this out. When you come back, I want you to be able to say, we've mapped out all the water and we've identified all these great opportunities. Okay. Yes, Jill.
The Laura had 3 goals listed on the last slide. Are those the ones that we're trying to meet? It was like map the water and then 2 more, which I've already forgotten.
I think that's.
As
the-
observe the operations, and then discuss, where we might be able to find the most water, and then develop reduction recommendations. For
Okay, all right, thank you.
Yeah.
Good. Any other questions before we break out? All right, let's give it a go, everybody. Go ahead and join your rooms. Except for Laura and Liz and I. And okay, because I always forget about that. All right, well, my group's back. Did you guys figure out what you need to figure out? Nope, you're on mute. Everybody gets on mute. Sorry about that.
I think that we left with a bit of I don't want to necessarily say confusion, but overwhelming feeling of the whole process, and not feeling like we had a good enough grip on the whole thing. It was kind of hard, kind of visually or mentally trying to visualize the whole process. So I think we did okay given where we started.
And it's hard, right? This is a hypothetical, pared down, unusual kind of an activity, and you didn't have a ton of time. So your group is probably not alone in feeling like, oh, we might have missed something, or we just didn't have enough time to digest it. Everybody, welcome back, and you've all been put on mute. So I'd love for people to unmute themselves and share. And Laura, I'm going to hand it back to you to manage this.
Okay, great. Well, thank you, everybody, for your good sportsmanship, shall we say, on this. This is something that, you would probably do as maybe a 2 to 4 hour site visit. So, kind of be able to get your feet wet a little bit more about the process. But, you're all professionals, so we figured we'd throw you to the wolves. You did great. In my group, we had some really fun suggestions and some opportunities, and people were thinking outside the box, and that is fantastic. So how about if anybody has some ahas that they want to share right now, that would be lovely. And then we can kind of walk through really quickly what I would have recommended after, what we could have recommended, something I have identified, and some of the things our students have identified over the years. So, but, there's always more. So, just because it's not on my list doesn't mean it's not a great opportunity, because there is a lot of opportunity in this place.
So what have you guys, what are some of the solutions or, opportunities that you identified? Just go ahead and unmute yourself and talk.
I'll just jump in and, sorry.
Go ahead, Karen.
I was going to say the laundry was surprising. That was really eye-opening. There's a real opportunity there for energy efficient washers. 370,000 gallons per year is quite a bit.
And hopefully nobody's saying there was washing machines there, really? that could be. And that is a great find. Super glad that you identified that. Any others?
One of the things that I found is there really isn't any indication that anybody actually looked into the efficiency of the process steps to see, how long it takes, how much water they're losing with drag out, just in general for both processes.
Oh, absolutely. Absolutely. This is kind of an old school process, an old school facility, right? You run into this a lot out there in the real world. We've been doing it this way for a while, and, and standard operating procedures. Yeah, I think we have one of those in the closet, right? I learned this from Joe, who learned it from, Sam, who learned this from Marilyn, and how telephone works, things change over time. So yes, there's probably a tremendous amount of optimization, and maybe even some lost knowledge in there from when it was originally designed to what they're actually producing and operating by now. Yes, I would say leaning their operation, using some lean processes is a great tool for continuous improvement. So after we get them over this hump, maybe that's another opportunity, is that they can really dig in and on their own do some more continuous improvement.
Stephanie, this reminds me of a comment that you made in our group. Do you want to just share your question? You remember that?
Which question was it? I'm sorry.
The question about tank changeovers.
Oh yeah, it's just I know this is something we also just experienced at our facility as like, why are there so many tank changeovers, and what is the threshold for it? Is sort of like a visual, this looks dirty, or is it X amount of cleans, or is it just every there was no real detail as to how often or why or the purpose of all of the changeovers.
Exactly. That's one of the things that I tell my staff and our students. I said, really, our value when we go into these places, we're not necessarily the expert on the processes, but we are the experts at asking why. Why is it like this? Why do you change it 2 times a day? What is the criteria that we're using for this? Is there a criteria? So that is a very important question, that why is it this way? And because that, there's sometimes a very valid reason why it's that way, and they'll tell you why it's that way. And if there isn't, they'll go, good question, I don't know. And that's an opportunity.
And that's true with disease reduction planning as well, right?
I had a question regarding, it says that they've increased by 500,000 gallons per year since the last sewer permit renewal. Do we know what time frame that is? Because if it's 2 years.
3 years.
Okay, so some of that 500,000 could be attributed to the new process that they just put in. Okay. All right, I just wanted to make sure I was understanding that.
Yeah, growth is something that companies don't recognize as a process. Oh, you mean I just doubled or tripled my line and that's gonna cost me more money? Yeah.
And Mark also in our group also asked, well, do we know how many new operators are, and was that reflected in the domestic water numbers? So there's a lot of different ways that could be impacting.
Well, I want to be super respectful of your time, and I want to run through, some of these other options just so that we can get ourselves on the same page and kind of remember what we were looking for here. And so this is what we started with, and this was kind of a key point that we wanted to drive home. Was we really wanted to start with that map part of the process and really make sure that we understood where all the water was going. And so what we should have learned was that we did not know where all the water was going based on our preliminary map of the process. And that was a key takeaway, is that we're missing water. Something's happening. Is this a leak in the system? Is that 500,000 gallons just a leak that is in the parking lot or under a piece of equipment that we can't measure and don't see or hear? Or is there additional uses in the operation? And in this case, there were additional uses in the operation. And so let me see if I can, the laundry and the softener and the RO systems were 3 operations that aren't part of your production operations. So these are operations, they are part of the facility, they do utilize resources, but they're not what we were focusing on when we focused on those 6 operation areas. And so there truly are 9 operation areas. And when you add up all of those, it turns out that those other 3 utilities, laundry, softening, and RO, were using 500,000 gallons of water. And so there's a huge opportunity. And so now here we are with, here's our map. And now we should be doing our 80-20 rule. Where can I get the most bang for the effort that we're going to put in? Okay, and so the laundry is the largest user. Surprise, surprise, the laundry of all things is the largest user of water in this facility. And that indicates that they have no idea how much water, energy, or time laundry is taking from their business. And so this is an opportunity for them to learn something. And so we looked through these processes. We found out the different areas. Process 1 really uses very little water. Process 2 uses more, as you all came up with in your analyses, and there is opportunity for reduction there. And then the other is where we have a large amount of opportunity. And someone in our group also said domestic fixtures may be something that we could look at. That does require an investment in remodeling. So if they're going to be doing remodeling, changing out the fixtures is a very good thing to do because you can save a lot of water that way as well. And so that's kind of where our opportunities were. So washing and coating line, the flow tanks, molding and tempering, the reverse osmosis reject rate, laundry, and the spray flow rinses were the biggest users, as well as fixtures. And so these are some of the efficiency recommendations that you might try. So in the laundry, you could implement high efficiency washing machines. And so looking through some of the high efficiency laundry usage versus traditional washing machines, I came up with a calculation that I could save 160,000 gallons if I just changed the washing machine. I didn't have to change the process. If I changed the washing machine and went to 2 rinse cycles instead of 3, I could get 230,000 gallons of water. And if I said, forget it, why am I doing all this laundry? I could just outsource that. And you know, again, it would be dependent on the cost, but we can talk about that later. That's a business case decision. Again, reverse osmosis. We had about 70% permeate. So that is, let's keep, instead of throwing away 75%, let's keep 70% of that water. Again, this requires some analysis to make sure that water still has the quality that you need. And then we'll get rid of 30%. Well, that saves you 100,000 gallons of water. And if you change the sprayer to a high efficiency sprayer, that's another that's 80,000 gallons of water. If you do both of those, you don't get as much, they're not additive. You get about 130,000 gallons of water. And tempering the water, if you control the temperature instead of just letting the temperature flow where the water leads, you can save 45,000 gallons of water. And domestic use, if you use water sense fixtures, you can shave off about 20% of the water use, or 100,000 gallons. So just there, we identified 645,000 gallons of water opportunity against their 500,000 gallon goal. So very good work, very good work. You got most of these. I heard most of those in our discussion. Excellent, excellent. You guys are great. You're worth every penny we're paying you. Really appreciate that.
Thank you so much.
So here's some of the business case justifications. So outsourcing the laundry is my favorite thing, because I would not do the laundry. But the labor to do that much laundry, 14 loads a day, if you assume all of that time, it's almost a full FTE of labor, which, you know, you can pick a labor rate and then you can say, okay, here you go. And these days where labor is so scarce, that may be a deciding factor for them. And so then you can see some of these other calculations for the water and the energy use in the different areas.
Laura, are you assuming that the outsourcing the laundry, that the laundry facility would just be hugely more efficient than we can ever be in our facility?
And they are. Now you've got transportation, you've got time, you've got, you know, wear and tear on materials, but they could probably contract this for less than what they're paying a single person to actually do the laundry. All righty, so that's where we came on the water treasure hunt. So thank you. Give yourselves a pat on the back, round of applause. You're all fantastic and great. Now, Pam, it is 5 of, as far as I am concerned. There is a tiny bit more. Really, it's just resources, and you can read those in the document that Pam is going to forward. So at this point, I think I will not go to that part of the program, and I'll turn it back over to Pam. And if there's other questions, we can certainly discuss that.
Yeah, we have 5 minutes. So if anybody has any residual questions that you want to ask Laura about the activity, about the work they do, about the opportunities you thought about, you know, let's hear it.
I have sort of a question as with regards to like resource conservation as a whole. So you outsource the laundry and you just are kind of offloading the responsibility of water usage on somebody else. Does that, I mean, your facility is not using the water, but somebody still has to. Do you have to look for somebody using less water or more efficient techniques? Like, does that count? It just seems like passing the blame to me.
It's part of your life cycle assessment, right? Okay, so what is the differential between it's the life cycle impact. Okay, if I have to, they do 14 loads of laundry a day. Most of it is rags and cloths, which they wipe off the products with. That is an industry for a reason, because if you are managing large amounts of textiles in that way, apparently you can do it more efficiently with less, with more, you have more incentive to invest in high efficiency types of cleaning systems, because it's an integral part of your operation rather than a peripheral part of your operation. And you have, you do the labor. But again, like many decisions like that, you do need to kind of do that life cycle think. So you take the box and you grow it and you understand the different inputs. Like I said, there's transportation involved. That's a greenhouse gas impact or a fuel impact or an air quality impactor. Okay, so we have to, kind of take all of those inputs. So yeah, what seems like maybe a simple decision may not be.
Right, and it's true with toxic use reduction planning, and it's a really, really good question, Stephanie. What we don't want to do is to be, shifting risks somewhere else. But this is a trade-off, and you really need to think about it. And so that question and a follow-up analysis is important. So I'm glad that you asked that. Any other questions or comments before we wrap up?
I have a question about drought periods. In Massachusetts, when that happens, there's lawn watering restrictions. Industries seem to be less affected. What is it like in Minnesota?
Yes, so lawn watering is a visual cue, right? You're not being a good steward. It may not be the largest user in your operation, but it is very visible. I would say industry does get put on curtailment. They get their permitting through the Department of Natural Resources now. So if they have their own wells, they get a permit limit on their well use, their drawdown. And in times of more water stress or in regions of the state that are experiencing more water stress, those permit increases don't just happen automatically. They have to really petition for them, and they may not get them. There just may not be enough water in some of those regions. In the southwest part of Minnesota, we have a very arid area. They are exclusively using groundwater in that area, and those groundwater wells are highly contaminated from a lot of agricultural impact. So many communities are feeling a lot of water stress. And so when you have an ethanol plant that's using gazillions of gallons of water per day versus a farm, versus a residence or a main street, who gets the water. And so really it's incumbent upon everybody to be able to conserve at their level. And that's one of the projects that we currently have going on because of that very reason, is to help go out into some of our more rural areas and try to just, look at the town, if you will, and figure out what we can do in all parts of our community.
Thank you. So thank you, everybody. And Liz just shared a chat, just commending you and doing such a great job and sleuthing things out. I agree. I think the groups did a great job. So it's 4 o'clock. We'll let you all go. If people want to stay and have a kind of a final question for Laura, that's fine. But I'm going to stop recording. Wish you well. And I will be sharing the slides and the materials with you all later. So have a great day, everybody.
Thank you, everybody.
Thank you.
Awesome.